problem. The characteristic equation of the system is given by s cube plus 2s square plus k plus 1 into s plus 3k equal to 0. Sketch the root locus as function of k. Find the range of k for which the system is stable, and also find the k for purely imaginary roots if exist and their roots. Here we leave the part sketch the root locus. This I will give a video solution how to sketch the root locus for this kind of system. Okay, we see find the range of k for which the system is stable. Here we are given with the characteristic equation and we are asked to find out the range of k for which the system is stable. Whenever you are asked to find out the range of k for which the system is stable, you need to apply Routh-Hurwitz criteria. So you know how to apply Routh-Hurwitz criteria. You can apply Routh-Hurwitz criteria by formulating Routh array. So you formulate Routh array for the system and you identify the limiting value of k at which any one of the element in the first column of Routh array is becoming 0 or not, or becoming negative or not. So the range of k for which all the elements of Routh array are positive, then for that particular values of k, the system is stable. And if any row in the Routh array, any one particular row, all the elements in any one particular row of Routh array are 0, then it indicates that there exists a complex conjugate force on the imaginary axis. So you find out the value of k where the roots are purely imaginary. So if you find out that value of k, then you can find out the roots where for which the value of k for which the roots will become purely imaginary. So now we see how to find out solution for this question. So the transfer, please note down the characteristic equation. Solution. Given that characteristic equation of the system is s cube plus 2s square plus k plus 1 into s plus 3k is equal to 0. So you formulate, you find out the coefficients of the characteristic equation. A0 is equal to 1, A1 is equal to 2, A2 is equal to k plus 1, and A3 is equal to 3k. Now you formulate Routh array. S cube, s square, s power 1 and s power 0. First you write A0 value. A0 value is 1, then A2 value. Here it is k plus 1. Then A1 value and A2 value. A1 value is 2, A2 value is 3k. Now you multiply these two, you write that product 2 into k plus 1 minus, then you multiply these two values and write the product 3k into 1 divided by, you divide this entire value with this 2. and this will become 0. Now, you simplify this factor and write this value in a simplified simple factor. So it is equal to 2k plus 1 minus 3k by 2. That is equal to minus k plus 1 by 2. So I can write this value as minus k plus 1 by 2. Now, you multiply these two factors and subtract this product 2 into 0 from 3k into minus k plus 1 by 2 and divide the entire value with minus k plus 1 by 2. You will get here it as 3k. And that means this value comes here. First column elements of Routh array are 1, 2, and minus k plus 1 by 2, comma 3k. So 1 is a positive number, 2 is also positive number, and to have this as a positive number, what should we do is minus k plus 1 by 2 should be greater than 0 and minus k plus 1 should be greater than 0, or you add my k on both sides, 1 should be greater than k or k should be less than 1. That means this value will become positive if k value is less than 1. And this 3k will become positive only when k is greater than 0. So the two conditions that we have are k is greater than 0 and k should be less than 1. Then only all the elements of first column of Routh array are positive. So what can we do? We say is the system is stable if the value of k that we have chosen is lies between 0 and 1. That means 0 less than k less than 1. And the system will have purely imaginary roots if k is equal to 1. So if k is equal to 1, what happens is all the elements in S power row will become 0. So you have to formulate auxiliary equation by selecting the elements of S square row. So the auxiliary equation is S square plus 3 into k is equal to 0. Sorry, 2s square plus 3 into k equal to 0. 2s square is equal to minus 3. S square is equal to minus 3 by 2. That is equal to minus 1.5. S is equal to plus or minus under root minus 1.5. Square root of minus 1.5 is I or j minus 1.5. So the roots of the characteristic equation are purely imaginary when k is equal to 1. The purely imaginary roots characteristic equation are S is equal to plus j under root 1.5 and s is equal to minus j under root 1.5, and the system will become unstable if the value of k is chosen greater than 1. So we have determined all the values that are asked in the question. Okay, so this is how you can solve any question that was asked on root locus.